Alright, so let's go ahead and continue with the notes. And let's talk about this using the table to estimate the derivative at different values. Ready? Yes? So if I want the estimation of the derivative at 0, what would be two good points to use? What points could we use?
-3 and 1.
We're going to use the ones around it. Okay? So we're going to use -3, 2 and
1, -3.
1, -3. Okay, would it have been okay for me to use 0 and 1?
Yes.
Yes. Would it have been okay for me to use these two?
Yes.
Yes. It's not okay if I use like 0, 1 and what? 10, 2. Or 1, 4 and 6, -7. Okay? They're too far away. They're way off. Understand? Yes? Alright, so it's an approximation. So all we're doing is getting an approximate using points that are close to it. Alright, so how would I find the slope using those 2 points? The slope formula. Anybody remember that? What's the slope formula? Good, so let's do it. So what's y2?
-3.
-3 minus
2.
2 divided by
1.
1 plus 3. Okay, so that gives me -5 over 4, right? Okay, so can you tell me what's happening at 0 for the function? It's decreasing. How do I know that it's decreasing? The derivative is negative. Does it make sense if I look at my table? So if I'm going from -3 to 0, what are my y values going? They're going down, so should it be decreasing?
Yes.
It seems to be decreasing all the way up until what?
6.
Up until 1, right? Yeah? It seems that from 1 to 4 something happened and my y values to go from -3 to 0, I have to go what? I have to go back up, so I have to increase again, right? Could something happen between -3 and 0 that I don't know? Could it increase and then decrease again and then keep decreasing? Yeah, so there's a lot of stuff that could happen between these two values that I don't know is happening, right? I'm just assuming that it's decreasing consistently, but it might not be. Alright, cool. Let's find the equation of the tangent line. What do we need for that? The point of tangency and the slope. So what's my point of tangency? Beautiful, 0, 1. Where'd you get that from? From the table. Awesome. What was the slope approximation? Alright, so let's do it. What's my equation of the tan line? Equals? Beautiful. That's it. That's how I want it. Easy? Let's try to make an approximation of the derivative at 1. So what would be the points that I use for that? 0, 1, and 4, 0. Okay. Those are points around it, so we can use them. So what's my derivative at 1? 0 minus 1 over 4 minus 0, -1 over 4. What can you tell me about the function? It is decreasing again. Why? It. What is it? The derivative. Very good. Okay, cool. What's my point of tangency? 1, -3. Okay, I'm getting it from here, from where I want it to be tangent at. And then I look at my table. And the slope that we figured was -1/4. So we get y plus 3 equals -1/4 times x minus 1. Good, Vanessa? Too easy? How about at 4, Anias? What would we pick?
1, -3 and 6.
Beautiful. This comes out on the free response. Usually it's like one part of it, and they'll ask you to approximate the slope of the tangent line at a particular value, and they give you a table. Okay, so it's really important that you understand this. So f prime f4 is approximately what? -7 plus 3, right? Divided by 6 minus 1, so that gives me -4 over what? 5? Was it still decreasing at 4? Oh, wow. But we said right before it that it was what? Increasing. So now at 4 it says it's decreasing, so that means it's going down. So is it really comparing the y values? From 0 to -7, is it going down? Yeah. And then from -7 to 2, that means what happened there? It increased. Okay? So what has to be true if I go from -7 to +2? What value or what axis did I have to cross? The x-axis, right? So that means I should have gone through what number? Through 0, right? So that means there's some place where it's equal to 0. So would IVT guarantee a 0 in between these two numbers? Yes? How could I prove that? What must be true for IVT?
The function
Must be continuous. Okay, let's assume that it is. Okay? Because they didn't tell us it was a polynomial, but if they would have told us that, then we can say yes, it's continuous. Alright, what's the second thing?
The function must be defined.
No, limit doesn't have to exist.
-7 is not equal to 2.
F of A must not equal F of B. So if I'm checking between here, does this y value equal this y value? No. Okay, what's the third thing I have to check? That the value I want to show is in between them has to be in between them. So here I said 0, right? So is 0 in between these two y values? Yes, -7 is less than 0 is less than 2. So therefore, after those three things are true, I can say IVT guarantees a value C, right? In the interval 6 to 10, such that f of that value C is equal to 0, the value that I'm saying. Where else could it be equal to 0? Where else could there be an x-intercept or a 0?
Between 0 and 1.
Between 0 and 1? Why between 0 and 1?
Because IVT guarantees.
Because I went from a positive y to a negative y, so I have to cross the x-axis to go from a positive to a negative. Do you understand? There'll be a question like that on your assignment. That's why I'm bringing that up. Cool? Alright, so let's finish this. What's my point of tangency here? 4, 0. My slope was -4/5. So my equation is y minus 0 equals -4/5 times x minus 4. Is that what you got? Do the last one. What would I use for 6, Ashley? 4, 0, okay. And 10, 2. Why am I picking those points? Because they're close to the one that I want, right? And they're going to give me a good approximation. Okay, again, could I have used 6 and 10? Could I have used 4 and 6? Yes, those are the three possibilities that AP considers okay. So what's f prime of 6 approximately? 2 minus 0 divided by 10 minus 4, that's 2 over 6, which is 1 over 3. So what can you tell me about the function? It's increasing. Why? Derivative is positive. Beautiful. I like the way you're talking now. Okay, what's my point of tangency? 6, -7. And my slope we said was 1/3. So what's my equation, Vanessa? Beautiful. Beautiful. Good. Okay, make it count, all right? We're recording. Good? Yes? Do we understand how to estimate a derivative at a particular point without giving a function? Yes? Pick points really close to it and use them to find the slope, right? How do we estimate the derivative if we're given a graph? draw the tangent line and come up with an estimation for your slope, okay? On the AP test, they will not give you a graph and ask you to estimate. They'll give you a table and ask you to estimate. At least that's what I've seen. Good? Yes? Alright, so we're okay with that? Alright, let's go ahead and continue with the notes, so I can finish it up. Okay, this will be a review of kind of what we talked about yesterday to see if you really understood it. And then I'll do the last part, and we'll be done. Okay? So, it says, the graph of a function g is pictured at the right, so this is the g function. Identify the following characteristics about the derivative and give a reason for your answers. Okay? So, in this problem, they want you to tell me the intervals where the derivative is less than 0. So that means that the derivative is what? Negative. Okay, so what do I know about the function if the derivative is negative?
It's decreasing.
Okay, so what I need to find in order to answer this question is where the function g of x is what?
Decreasing.
Decreasing. So if you can find those intervals where it's decreasing, you can answer this question. So where is it decreasing? From what x to what x?
-4.
So from -4 to what?
-2.
-2, okay. And from where else? 1 to negative infinity?
So positive infinity.
Or positive infinity?
It's on the x-axis.
Very good, Axel. It's on the x. So what's the mistake that people make if they say negative infinity?
They follow the y.
They're following the y values, right? And when we're doing intervals of increasing and decreasing, it has to be x. So it's from -4 to -2, and from 1 to infinity. Alright, so let's write that, but it also asks us to give a reason. So we're gonna say the derivative of g is less than 0, meaning it's negative. Where? -4 to what? -2. When we're labeling intervals of increasing or decreasing, we never use brackets, it's always parentheses, okay? Now how do I say that and another one? Union, right? So we do this U for united, and we put the other interval. So that would be from 1 to what? Infinity. So let me tell you a quick joke that I learned this weekend. Okay. What did 0 say to 8?
What?
Nice belt.
Nice belt. Oh man, you already knew it?
What?
Oh, okay.
Nice belt?
You didn't know that one? Nice belt, right? That's what it is.
You haven't heard it?
No.
Anyway. Alright, so
I heard you haven't heard it.
the derivative is less than 0 on these intervals because the original function is what? Decrease. Okay? So we're going to justify our answer. Justify why we're saying those intervals. Good? So the same way I broke that problem apart, I want you to break apart the next one. So think about it. What is it asking? What is this saying here? What's greater than 0? What is g prime? The derivative. So that means that I'm looking for where the derivative is what? Positive. What does that mean? What's increasing? The derivative is increasing? No. The function. So I'm trying to find where the original function g of x, which is this graph, is what? Increase. Okay, so let's find where it's increasing and let's label it. Or highlight it if you want. From where to where? Going up there, right? And it's also going up right there. What are those intervals? Negative infinity because it's coming from over here from the left, not because it's coming from the bottom, right? So negative infinity all the way up until -4 and -2 to 1. Alright, so let's write it out nice and pretty. So the derivative is greater than 0 on the intervals -infinity to -4 union negative 2 to 1, right? Why? Because the original function is increased. Good job. Cool. What's the next one asking for? The values of x where the derivative is equal to what? To 0. So when would that happen? When would the derivative be equal to 0? Maximums or minimums. So I'm trying to find where the original function g of x has a max or a min, right? So where do the maxes or the mins occur? Looking at this graph. At negative 4, at negative 2, and at 1. Let those three x values. So let's just write it out, okay? We can say that the derivative is equal to 0 at x equals negative 4, negative 2, and 1. Why? Because what has a maximum? G of x, the original function, has a